How's it going? Day 40. We finally made it back for some more exciting challenges that are going to be happening. It is Friday. The weekend is upon us. I'm pretty excited. Later on, I'm going to be having one of my Freak Out Friday streams. So, yeah, something to keep me on my toes. I'm looking forward to that as well. For now, let's just continue on with our challenges, shall we? Just make a little post over here. Go. Let's close the rest of the stuff. Not using that. So we need a sum or odd Fibonacci numbers. Given a positive integer number, return the sum of all odd Fibonacci numbers that are less than or equal to number. The first two numbers in the Fibonacci sequence are 1 and 1. Every additional number in the sequence is the sum of the two previous numbers. The first 6 numbers of the Fibonacci sequence are 1, 1, 2, 3, 5, and 8. For example, sum fibs 10 should return 10 because all odd Fibonacci numbers are less than or equal to 10. Because they're 1, 1, 3, and 5. Okay, so let's see, what do we know? We know that there's a...
Hamayas is just following the family.
James! Welcome to the family! Good to have you here. Okay. So what do we know? We know the sequence is n plus the previous number equals the current sequence that we're on. We can also check if, because they're odd, the numbers are always odd. So if we use modulo 2, we'll know. I'm wondering if we can use reduce. See which is the best way to do this now. So what do we have to return? We have to return the sum. Okay. I'm definitely gonna have to use reduce. That's for sure. Okay, so let's start somewhere. I've no idea where we're even going to begin, but we need to start at 1 because the sequence starts in 1. So let's do like current num equal to 1, and then hey Christopherus, how's it going? Here to watch me suffer with maths, huh? So num for I less than num. A while loop's going to be quicker than a for loop. So I guess we should use while. While current number is less than num, then we want to gonna want to check if it's divisible by 2, because if it's even, it's not a Fibonacci number. So if current num modulo 2 Twiddly-doof, hey, Fibonacci sequence in math is also a recursive sequence. Right, yeah, because it goes in order, right? Or while and for loop are exactly at the same speed. I'm pretty sure I read an article somewhere that said the while loop was faster than the for loop. Or has that changed at some point? Interesting. Let's see what we get now. What is being passed in? So we go 1 1 1 1 1 1 1. I'm not also right. This means they probably want you to use recursion, so check it out. Okay. We also need a way where we update current number, else our loop is going to continuously run. I'm surprised it's not continuously running. Forgot about that. We need to update current number. We also need a previous number, don't we? Because how do we keep track? This is what we would use. Oh, you would use this in reduce. Hold on. I want to do this in reduce. I think it's going to be better. Let me just get this out of here, and then we should push this into an array. What should we call it? Like Fibonacci array. Right, and then whoops. No, what am I doing? My hands today are not working with me. We're still gonna have it while it's less than the current number. Well, actually no, we could just do a standard current number is gonna be 1. So less than number should be fine. No, that should be fine. If I do -1 and -2, because we need to update current num as well. But I think this is going to be current num. I'm going to call this I for our recursive sense, or just index. And then we need to update index is equal to our Fibonacci array. Then we need to get the length of it. So the Fibonacci array.length -1. So we got 4. Because the array's length is empty. Let's test with 1,000. Two. I'm not getting... We're not adding on to that, so I'd have to push 4 and 1,000. It's gonna be a mess now. But then I should take my array and then we can reduce and then we need the might as well say previous num and current num if we're gonna go all out. So previous and current, and then let's not forget the brackets that I keep forgetting. Testistoners, hey, how's it going? You guys are active on a Friday, hey? You guys excited for the weekend? You guys got any plans? This is where I need to do my check, where we do current number. Is it current number that I was thinking? Because we need to check if it's is it divisible by 2? Gonna have to figure this out now. Wait, we try to find the Fibonacci numbers, so it's got to be not divisible by 2. But that doesn't give us anything. Wait, if we had 10... Okay, the remainder is going to be 0, so we need to check if it's not 0. So, not equal to 0. That would have given us that, but... why am I not getting anything? Previous num, current num. What are we up to? Trying to find the Fibonacci sequence in a given number. And I thought I was onto something, but clearly not. I did push the number from this into the array. The array contains a number. So we should have gotten 1 and 3. Oh right, we gotta sum them, don't we? So return previous number plus current number, because reduce. Else, if it's not divisible by 2, which is 0, we would return the previous number. So 4 should return 5, because it's 4 and it starts at 1. So I should have 1 in my array. Push number to our array. Why is it not pushing 4 to our array? Should be a 4 there. I don't think your Fibonacci array is correct. Yeah, I'm trying to see that now. Because of my index? No, because that was supposed to be that way. Length minus 1. But if I have 1 in my array and I'm pushing number to the array, shouldn't I have 1 and 4? Yeah, I do. One and 4 are not Fibonacci numbers, no they're not. Well, isn't 1 in the sequence? 1 is. think I'm gonna go back to my while loop. So while index is less than I'm gonna undo this and I'm gonna have my while previous number is less than num, then instead of having my reduce there, I think I'm just gonna do it here. So if the current number when divided by 2 is not equal to 0, do we have sum? Or are we just going to do total? Then we're going to update total plus equal to the current number. Then outside of this loop, after that if, we should update our current number and add the previous number to it. And then the previous number should equal the current number. And then we should set current number to be 1. Then I won't need the array. Let me just see if I'm missing anything now. So previous number we initialize at 0 because obviously we don't have the previous number yet. The current number should always start at 1. So we've got that. Results that we're going to return being total is going to be at 0. And then we have our while loop. Oh, this should be equal to as well. Less than or equal to the number. And this shouldn't be the previous number. This should be the current number. Because we need to start on 1. So while current number is less than or equal to the number, and if the current number divided by 2 is not equal to 0, then we can increment total by current number. And outside of our loop, we are updating current number to equal the previous number, and then the previous number equals the current number. Is that right? But some fibs 4 should return 5. And we only... Yeah, no, like I'll put my hands out when it comes to maths. Like no problem there. Ugh. How far off are we though? What am I doing? Hold on, previous number should be the current number minus the current number. Sorry, the previous number. There we go. That's what was missing. Couldn't just set it to 1 because then it's always going to be the same. So then 1000 should give us 1785. Yeah. Okay. Yeah, that makes sense now. Because current number is going to be 1, and the remainder is going to be 1. So it's going to be 1 plus the current number plus the previous number of 0. Previous number is the current number minus the previous number. And we go down in sequence. So current number is 1. And 1 is less than 4. The current number of 1 modulo 2. So that's false. So we're going to have current number of 1 plus equal to previous number 0. Previous number is equal to the current number, which is 1, minus the previous number 0. We got 1 there. And then we just keep going. Now I could have used reduce, which I would have had previous add current as the accumulator. Well, total would be the accumulator, wouldn't it? I mean, that works, I guess. You know, there's one thing I realized. I should have been putting my solutions in like a little GitHub file. And I realized a bit too late, so I don't think I'm going to start now. But that would have been a good way for me to actually realize, since FreeCodeCamp doesn't save your solutions, it would be nice to come back and then realize, okay, I did things this way, I could have done them this way now. Unless I look back on my old streams. Oopsie. Leave this in. Cool. So that's done. Should definitely save these. I guess the projects are stuff that you can look back on, because those are things that you actually link to CodePen, and I could upload to GitHub. But yeah. But too late to do that, I guess.
Anthony Provera 88 is following the family.
Welcome, Anthony. Good to have you here. Yeah, let's move on. That one got me. Primes, I think I'll do better. I'll do better at primes than I would at the Fibonacci sequence. So, sum all the prime numbers up to and including the provided number. A prime number is defined as a number greater than 1 and having only 2 divisors, 1 and itself. For example, 2 is a prime number because it's only divisible by 1 and 2. The provided number may not be a prime. Okay. So we need to first figure out if the number is a prime. So should we add a... Probably add a function here to check. Let's do it. Function. Are you... what was I gonna do? Oh yeah. Are you Optimus Prime? We'll take in num. And so we know that if a number is prime, it's only divisible by 1 and itself. The 1 and itself so 17 divided by 1 would still be 17. And 17 divided by itself would be 0. Nope. Sorry. It's 1. Not 0. I'm just trying to work out the math now to figure out how I'm gonna do this. Whereas if you tried 17 divided by 2, you wouldn't get the same. And 1 being by 1 and 2. It's only divisible by 1 and 2. And this isn't. And then we need to sum that every prime. Okay, I think I got it. So, if it's divisible by 2, we should probably have... We should probably have a for loop. Let... we call it like divisor. We're gonna have that as 2 less than or equal to num, and then divisor plus equal to 1. And then we're gonna return a boolean from here. So this can be false if it's not. Hold on. What happened to my... How did you get down there? No idea. Anyway, so now if we pass in 2 to our function, should hopefully get For 5 being a prime number, what the f... Okay, 2 and 5 are definitely prime numbers. I messed up my order. So if it's... Oh my god. Oh, this is why I don't start straight after working out. Fuck's sakes. Thank you. So 8 would not be a prime number. 9 would be a prime number. Hold on. But 9 isn't a prime number. Seven is, 13 is, 14 isn't, 15 isn't. But why? 15 would be, because 1 in itself. Yeah, that's what I'm thinking. It's divisible by 3 and 5. So we kind of fail here, don't we? Hold on. Hold on. Hold on, hold on, hold on. Let's get out of the for loop. Because the recursives... If it gets to this point, we can return true, right? Is this gonna clash with that now? I don't know, we'll see. But let's do sanitation first. Because if we get... trying to think now. What if num was 1? 1 is not a prime. So we could return 0. So if num is equal to 1, then I guess we'll just return 0. So we cover that check. We cover that. The only problem now... Okay. So 11 is a prime. 13 is a prime. 15 is not a prime. 17 is a prime because it's 1. 17, the next one should be 19. 21 shouldn't be because okay, so that's good. So it's just the looping that we had. What else is there? 7 was 9 because of 3, so false. Okay, good, so we're fine. Just thinking if that's necessary. Now we need to sum them. We just have like an if here. If not are you Optimus Prime and pass in the number. So if we're not a prime, we need to go down the sequence. Why do I keep doing this? Okay, so if we're not, then it needs to be return. Return! What are we gonna return? Could call the recursive function, couldn't I? Call yourself and then the number -1. Will we need that though? Because now that we know... Let's come back to that. So it's every number that's a prime in 10. Let me just try wrap this around my head. Just draw up the prime numbers real quick. So we got 2, 3, 5, 7, 11, 13, 17. Some prime 10. Sum all the prime numbers up to and including the provided number. So if our number is 10, it's 2. So it's going to be 2 plus 3 plus 5 plus 7. Which gives us 17. So that's how we're getting to 17. Because all the prime numbers up until 10. So now I need to call this each time, taking the number -1. Because here, num is going to be, when I get there. So if we're passing in 10, let's work on their example. Good. And before you return, just want to make sure that I got that right. Okay, so we get 10. Now we would go down -1. So it would be 9. Then it would be 8. Until we get to our first prime, which is 7. And for each true, we want to add that to a sum. The sum of all primes is 0, and we want to sum of all primes plus equal to num. Okay, so we got that down. Christopher, are you trying to solve this? Yeah, I am. As you can clearly see. Not doing such a great job. I know what needs to happen. And now I'm trying to work down. That's why I brought out the prime numbers. Because if our example is 10, we need to keep going down. And for each prime number that we find, we need to add that to our sum. I wonder if I can wrap this all in a while loop. I'm gonna misspell this just because I don't want it to fire off until I have the logic. Let's do index less than num. Do we want it less than num? Because if it's 10, are we going to get to the final one? Well, index is less than num. I guess we could just do index plus 1. Then have this over here. Actually won't need to do that anymore, because we can have it all in one function. Then index Oh no, we already have it at num. So index actually needs to be 0. Start at 0. Increment by 1. The only problem with that is, for each, this will only increment for each true. So this needs to be, this is a for loop, that is the if. Okay, so this will be on each occurrence while it's less than number. Index starts at 0. So if we add 10, yeah, and this happens afterwards, and the first one occurs. Okay, that should be fine. Okay. Can I use number? I can't, can I? So I'm just going to call it loop num. Just trying to figure out what I want to do. Am I going to have time? I got 7 minutes. Woo! So let loop number equal to number. So that's going to start at 10. Okay. And at the end of it, you want to set loop number minus equal to 1. Okay, cool. Then block that out. And I'm not going to return. Keeps initializing on the beginning of each loop. There we go. So we've got 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We never wanted to go to 0. So that should be fine. And then we replace every occurrence of num with loop num. We might have to break out of that though. And then we de-increment, and then we set the index again. So that at least is working. Only thing now is our sum of all primes is 0. Why you do this? So num is 10. What is loop num? Shouldn't it be adding all of those numbers each time? Sum of all primes plus equal to loop num. But we get 0? Because then I had it as a function. But I might not need it as a function anymore. So I can just literally have it as a while loop. There we go. But now, because I didn't return that number, so it couldn't update that. But now we can only add loop num. So we have an else here. This needs to stay for the loop to continue. This needs to stay to break the loop. It's either I need to break this. Why did I think that the else would be fine here? Because it's not a prime number if it's divisible by its divisor. And the loop number is not equal to the divisor. So that's when we know it's not a prime number. But then why wouldn't else work? Because that covers every case, doesn't it? So how do we get 269? So I can't have it there. Because it gets out of this. So do I have to break? But if I break, it's still going to go down there and add sum of all primes plus equal to loop. So we can't do that. What if we removed whatever loop num is there, because it's going to add it? Then we get left with -6. Amazing. That's exactly what I want to see. Okay, let's rethink this again. I need to take number and step through it each time and de-increment by 1. And for every prime that I find, we need to update sum of all primes. Okay, hold on. What if we gave it loop num instead? Let's just think of this for a moment. So if we gave it loop num starts at num. So it would start at the given one, and the index is going to be less than num, so that works. The indexing works fine. Then we have the for. Instead of returning anything, we can just return. If it's empty, we just return out of there immediately. And if it gets to this point, instead of having that, we would can it access loop num though? Because it's in a function now. Either way, this would have to return loop num, because that is our prime. That fails on the first go, but it's not going to continue. So I think we need to move that while loop outside of that function and keep this. Yeah. While index is less than num, loop num minus equal to 1, index plus equal to 1. If I'm not mistaken, if we console.log loop num, perfect. So we do what we need to do inside of here. So test is 0, test plus equal to the function 10, and we're passing it in a number, but that needs to be loop num that we're passing it in. We can't really clash with that now. That has to stay num. We're passing 10 in. But it's not using... Okay, so once we get that... $10 needs to be loop num, so we need to pass loop num into it. Loop num becomes minus equal to 1 at the end. Like that. Index increments. So if we don't fail that, we're going to return num. Otherwise return 0. Because otherwise return without anything would return not a number. But now we get 18 instead of the required 17. Is that because start at 1 and 1 isn't a prime? Do I have to set our index to 1? Let's see what happens when we try 977. No! Why did I do this? Why did I put it there? It's not where it was supposed to go. Okay, so we get 73156, so that works. What a mess. What an absolute mess. Okay. So we are going to return test. So test should actually end up becoming sum of all primes. Like that. And return sum of all primes. We did it. So I didn't need to go through the long complicated path in the end. A simple for loop. Now if I could just clean this up. We're not going to return values, we're not going to have any extra calculations. We're just going to do it all in a simple while loop. The sum of all primes starts at 0, index starts at 1, the loop number is equal to the number, and the function is simply check if it's a prime. If it's not, return 0, if it is, return the prime number, and we have a while loop that just loops while it is less than number. So if it's 10, 9, whatever, then we increment sum of all primes by our function, which returns the prime number or 0, depending on if it's a prime or not. Then our loop number, which started at their given number, gets de-incremented by 1, and we increment our index by 1, so that we don't have the little infinite loop that I just had. And when we're done, we just return the sum of all prime numbers. Wow. Yeah, I absolutely hate math still. But we did it. So how long will it take to like do a super long number like that? Did that thing just change before my eyes? Like,
This world has room for everyone.
I swore that changed. Did that not change? Like, as I was...
Good Earth is rich.
How does that work?
It can provide for everyone.
Remove the
Way
colon.
of life to be free and beautiful.
How does that work? Remove... What? What is even going on right now? I guess the while loop was still busy. That's crazy. How does that work? You guys see this? The value changes. Okay, it stays at 39, 390,000. That was weird. Not sure if like some overflowing was going on or what. I like this one. Even though I don't like the maths, the logic behind it. We're gonna save this. There we go. Cool, and that's that. And that is time for me. I have to run off now. This now stands, the academic honesty policy? What's that? The AHP. Did you see that though? That the value changes? This is like going back to math again. Starts off at like higher grade and moves on down to high school maths. That's a thing you had to accept before claiming a certificate? Yeah, I mean by that case I should ban everyone from my chat for helping me, right? Because we live stream everything and a lot of the solutions came from chat. Because generally a lot of times I know the logic, but putting it together, it seems I always fall back to loops to solve a problem. And then there are ideas that you can do, but I don't follow them. And then instead of having things less complicated for myself, I end up making them far more complicated than they need to be. But it's fine, I guess it'll get easier in time. And at the end of the day, you do this for yourself, not for anyone else. And when I pass all of these, I can actually start working on projects, which I can't wait to do. So I really want to get through these, because there's nothing new that you're going to learn, and a lot about it is maths, and I'm never going to use the math side. Like, that's a fact. I never want to work on the math side of things. I want to build things, and they're not going to revolve around maths. So the objects and arrays are fine, but when it comes down to maths again, man, we still have a while to go though. I think we've only just barely hit the halfway mark when it comes to this. Yeah, just slightly over halfway. See, the other ones will be fine, but these maths, I can't wait for them to be done. I think that's the last one. That's going to be objects, object arrays. Hard to tell what that will be. That might be maths. Not sure what these two would be. Math is logic. There's different types of logic though, and you definitely do not need maths in many circumstances. Or at least a very basic level of understanding of maths versus the next level maths we're doing here. Remember, it's been how many years since I've been to, like almost 10 years since I've been at high school. So like trying to recall all of these things that I've never used before is something quite different. Am I going to need maths here? We'll see, because these projects I always do on my own without any help. So that's what I like. I don't think anyone helped me when I did my projects, did they? Were you there when I did my... Well, you couldn't really help with the CSS stuff, could you? I mean, what can you really say? Change this color. So this will be a little bit different. But then we got our front end stuff. So I finally get to work with all of these, including Sass. I think these will like fly through. JavaScript has been like the longest one that we've done so far. I think I'm what, on 21 episodes of these? The data visualization, you had a lot of fun on that. The APIs I'm looking forward to, because that means I get to finally work with Node. And this will be interesting, because I did quite a bit of InSec when I was in the IT sector, but I think this might be a little bit different, so we have to see how that goes. And I don't know if I'm going to stream the code interview prep. Maybe. This is like a good way to like finally challenge ourselves after everything, isn't it? Create a hash table, man. Okay. Maybe we'll do it. We'll see. Jeez, how many are there? Did I see Discord? Oh yes. Ah, Discordian date. I was like, use the Discord API, make a bot. Okay, definitely not doing this one at all. Jeez, how many are there? What the fuck? 480! But you know, the completionist part of me wants to do this, but this is all math. I can't. What I'm gonna need is like a math genius in the chat, just sitting here and just, you know, explaining things like I'm 5. 10,000th and first prime. Okay, maybe that's not so hard. Not as efficient, but the code that we used, we could just use that, and every time we find a prime, increment it by 1 and keep going up. And when we get to 10,001, there's your number. Oh, I'm not even gonna compete. There are people that will do it in probably like 1 line of code, and I'm okay not being good with maths on that level, because you do not need a super high understanding of maths to program at all. And besides, remember, a lot of what I want to do is game dev. And you're not going to be using Fibonacci sequences in a game to calculate certain things that happen to a player or enemy or object. You know what I mean? That's what I'm referring to. So yeah, maths of like, you know, multiplication, division, subtraction, all those things. Yeah, basic stuff. You'll use that. But I mean, really? The sequences and like the formulas? Like, where would you use that? Like, legitimately, if someone knows, I would like you to reach out to me and share with me where a game, or yeah, I think a game, because that's what I'm interested in. That's what I eventually want to get into, is game development. Where a game has used these complex algorithms that isn't a math-based game and that isn't calculating things like physics, because that's not what I'm interested in. Again, you have a separate team for that does that. Like, actual game development. Because your engine will usually take care of those things. Unless you're, of course, you know, building your own engine from scratch. And again, you're going to have a team that specializes in different things. Game dev without advanced math? No way. Hold my water, Chris. Hold my water. Just you wait. I'm gonna like screenshot this now. Christopher's game dev without advanced math. No way. Done. You're on. Maybe I know advanced maths, but what we just did, if that's advanced math, then no way. If that's like next level maths, then okay. Alright, but I have to go now. I've got my stream starting in an hour and 5 minutes on my other channel. Freak Out Friday. I get to finally relax and enjoy. It's been a chaotic week and I can't wait to unwind. Hope you guys have an awesome one. Enjoy your weekend. I'll be back tomorrow, hopefully finishing off these last few challenges so we can actually move on to something a little bit different. JavaScript has now been something that we've been constantly working on for quite some time, so it'll be nice to actually move away from it for a bit and then come back to it again. That's going to be fun. But yeah, until then, until next time, bye for now.